Selection of honeybees. A young bee emerges from its cell. It will be one among 10 to 40,000 others which together form a colony of honeybees. Its survival depends on membership in such a community. Each colony has only one queen. She alone is capable of laying eggs and thus is the mother of all bees in a hive. Her attendants, the nurse bees, lavish intensive care on her, and this allows her to lay up to 2,000 eggs per day. The nurse bees also feed a glandular secretion to the larvae which hatch from the eggs, and in this way they exert an influence over the quality and quantity of the brood reared. Similarly, the expression of most of the characteristics of a colony is determined by the interaction between the queen and her workers. For its daily needs and winter stores, a colony collects annually about 25 kilograms of pollen and 200 kilograms of nectar. That quantity of nectar may be concentrated to about 70 kilograms of honey. Bees communicate with each other by means of a dance language. This tail-waggling forager is informing other workers about the direction and distance of a newly discovered source of food. Social food exchanges between them provide more information about the quality of the nectar. The construction of honeycomb is another example of the close cooperation among the workers of a colony. In order to produce wax, bees form dense chains during comb construction. In the form of tiny scales, the wax is secreted from specialized glands on the underside of their abdomen. The scales are removed with the mandibles and are worked to form an amazingly precise and strong cellular structure. Their brood is reared and honey may be stored. The overall productivity of a colony is therefore the sum of the manifold contributions made by queen, workers, as well as drones. In order to make optimum use of the varied hereditary characters in a breeding program, a study of the genetics and the mating process of honeybee queens is unavoidable. A virgin queen mates in free flight with as many as 20 drones. This is shown here in an experimental setup. The drone's semen is stored within the queen's reproductive organs, shown here in graphic simulation. At the tip of the abdomen is the sting chamber. It is separated from the median oviduct by the vaginal valve fold. Attached to the oviduct by a narrow channel is the spermatheca. The median oviduct forks into a right and left lateral oviduct. These lead to the two ovaries, which each consist of 120 to 160 ovarioles. The first drone mating with the queen forces his semen into the median oviduct. The mass of sperm of subsequent matings, only 3 more are shown here, force the semen into the lateral oviducts, dilating them considerably. After the mating, the queen compresses the semen back towards the vaginal valve fold. This makes 5 to 10% of the semen, up to 7 million sperms, enter the spermatheca. Thoroughly mixed, the semen is used to fertilize eggs over the next 2 to 4 years. Most of the semen is expelled as dry pellets. Just before an egg is laid, it receives a tiny droplet of the mixed semen. As many as 10 sperms may penetrate, but only one of them can fuse with the egg nucleus. Eggs laid in drone cells are an exception. They remain unfertilized. Multiple matings thus cause a brood of several groups of half-sisters, which all have the same mother, but are the daughters of several fathers. When drones with pronounced body markings had mated with a queen, their genetic differences express themselves in their daughters. Here, the genetic transmission of dark and of leather-colored abdominal shadings, as well as yellow rings, is evident. Furthermore, some workers have light, unpigmented eyes, while others have shortened wings. In spite of these complicated family differences, it is possible to breed honeybees. Of course, the composition and the relationships of the breeder colonies must be known, and their characteristics must be combined skillfully. All efforts of selective breeding must be directed towards producing a gentle, productive as well as disease-resistant bee.
Honig. Willst du mal lecken? Mhm. Dann mach mal mit dem Finger. Mach mal rein. So, guck mal. Okay, genug.
Apiaries in a variegated landscape with an adequate supply of food make ideal performance test bee yards. About 20 colonies should find sufficient forage all the year round. In order to emphasize the genetic differences between colonies, the management of all stocks must follow a uniform plan. Making hives face in different directions reduces drifting. Shook swarms or package bees of equal weight are highly suitable for setting up new testing colonies. Sister queens which had mated in the same mating apiary are introduced to all colonies to be tested within the same group. The queen cage is closed with a plug of candy and suspended between frames of foundation. After opening the swarm box, the brood chamber is placed on top. The bees will cluster around the caged queen within the next few hours. The lower hive body and the swarm box are removed later. Finally, the bees are given a supply of sugar syrup. All colonies in the apiary receive the same treatment. As an alternative, the young test queens can be introduced to established colonies. These should be healthy and of comparable strength. One method is the direct introduction by substitution, but this is only likely to be successful when the young queen produces eggs. Pheromonically, she is then of equal value to the bees and is usually well accepted. The old queen must be found first. She should have been free to move about in the hive until then. Had she been caged, the bees could have felt queenless and could have started to raise queen cells. That would endanger the acceptance of the new queen. The old queen is picked off the comb and is temporarily caged. Just before her introduction, the young queen is removed from her mating nucleus. Her number and markings are registered into the breeder's record book. For the time being, the old queen may be introduced to that mating nucleus until, after full evaluation of her data, it is possible to decide about her future use as a breeder queen. Over the next few hours, the bees will release the new queen after eating away the plug of candy. For a fair performance test, the introductions should be done before the end of July, so that a queen's inherent qualities, such as wintering and spring development, can be assessed in a colony consisting of her own progeny. All details of the queen's identity are entered on a record card, which will remain with her throughout the test. A first check is made after 5 to 7 days. The presence of eggs and very young larvae is evidence of a successful introduction. Colony strength is assessed in all stocks about 4 weeks after the introduction of new queens. Unequal bee populations could have been caused by differences in the past, or maybe due to variable qualities of the bees in the shook swarms. Therefore, it is necessary to estimate colony strength as well as the areas of brood. Obvious differences are levelled out at once by the judicious removal or addition of brood. One frame of brood roughly corresponds to the number of bees which densely cover 2 frames. After this last operation, all colonies in the apiary should show comparable strength. Finally, all stocks are provided with sufficient stores for overwintering. Here it is done by adding the food chamber containing frames of honey. Any surplus spring honey is suitable for feeding. Shortages are then made up by feeding sugar syrup. All hives should show similar weights. The concentrated sugar syrup will be taken down within a few days and is stored in honeycombs. At the beginning of October, all stocks should have at least 20 kilograms of winter reserves. The first cursory spring examination is made when willow catkins are in flower. Food reserves, the presence of brood, and the health of bees are checked. As soon as colony strength begins to recover, the full evaluations are